Let me start very slowly, because this question deserves slowness. Not speed, not excitement, slowness. Look around you for a moment, not in a dramatic way. Just look. Your hands, the chair, the phone, the air, all of it is made of atoms. That much we're told very early. But here's the strange thing, a deeply strange thing. Why is any of this still here? Why doesn't it collapse? I don't mean emotionally, I mean physically. Why doesn't matter just fall inward and disappear? If you think about it honestly, the usual answer doesn't really answer anything. We say atoms are stable. We say electrons stay around nuclei. We say forces balance. But that's not an explanation. That's just a description with confidence. Imagine I tell you a building is standing because it's stable. You'd say, yes, but why is it stable? What's holding it up? What stops it from falling? That's the question we almost never slow down enough to ask about atoms, because if you did slow down, you'd notice something uncomfortable. Inside every atom is a strong attraction, parts that want to come together, parts that by all common sense should crash into each other. So why don't they? Why doesn't the universe just shrink into nothing? This is where most explanations quietly wave their hands and move on. They say words like orbit, or energy levels, or quantum, and somehow we're expected to feel satisfied. But if you're honest, really honest, those words don't settle the discomfort. They just put a label on it. So let's do something different. Let's not rush. Let's not pretend understanding. Let's stay with the confusion. Picture a crowd of people packed tightly together, all wanting to move toward the same point in the center. No rules, no space, just attraction. What happens? They crush inward, they collapse. Now imagine you tell me, don't worry, they won't collapse because they're arranged nicely. Arranged nicely how? This is exactly where atoms become strange, because electrons are attracted inward. That part is not mysterious. Opposites attract. That's intuitive. The mystery is why they don't finish the job. In school, we're shown pictures, little dots, little paths, little neat circles. But those pictures quietly lie to you. They suggest electrons are tiny planets calmly orbiting, as if they chose to stay polite and not fall. But nature is not polite. Nature doesn't follow diagrams. So already something feels off. And here's where the real discomfort begins. If electrons were truly just tiny objects attracted inward, they wouldn't hover. They wouldn't pause. They wouldn't decide to stay at a distance. They would fall. So something must be resisting that fall. But what? It's not a wall. There's no barrier. There's no little cushion around the nucleus. There is only emptiness. And yet, that emptiness behaves in a very unempty way. This is where textbooks usually speed up. They introduce a rule, give it a name, and keep going. But let's sit inside this contradiction. Attraction is pulling inward. Collapse seems inevitable. And yet collapse never happens. So the real question is not what is an atom made of. The real question is what stops collapse. Think about holding your breath. You can do it for a moment, but there's a pressure, a resistance. Not because someone is pushing you, but because holding things tightly costs effort. Now imagine trying to squeeze something infinitely small. The tighter you squeeze, the more uncomfortable it becomes. Atoms behave like that. Not because they have feelings, but because nature has rules that don't match our intuition. When something is forced into a smaller and smaller space, something pushes back. Not like a spring, not like air pressure, but like a fundamental refusal of nature to allow perfect confinement. This is not obvious. Nothing in daily life prepares you for this idea. We are used to things sitting still. We are used to objects having positions. But at the atomic scale, sitting still is incredibly expensive. It costs something. And here is the quiet truth. Textbooks rarely pause to emphasize trying to pin something down, to lock it in one place, requires energy. Not because it's moving fast, but because being too confined is unnatural. So electrons don't stay up. Because they are balanced like a book on a table. They stay because falling inward would cost more than hovering. Let that sink in. Atoms exist not because forces cancel perfectly, but because collapse is too expensive. That's a very different story than we're usually told. And it changes how you see everything, because stability is not passive, it's active. Existence itself is a kind of tension. Matter is not relaxed, it's constantly negotiating with the rules of reality. The atom is not a peaceful structure, it's a compromise. Attraction pulling inward, confinement pushing outward. Not as forces you can touch, but as principles you can't escape. And already we're far from common sense, because common sense says things fall until they can't. Reality says things stop because stopping any further would be worse. This is not how our minds evolved to think. We like clean answers. We like resting states. But the atom is not resting. It's hovering on the edge of what's allowed. And this is just the beginning, because once you accept that existence itself requires constant resistance, you start to see the universe very differently. And that's where we'll go next. So let's go a little deeper now, but slowly, not deeper with harder words, deeper with patience. We said atoms are a compromise, not a balance in the everyday sense, but a negotiation. Attraction pulls things inward, that part feels familiar. Magnets do it, gravity does it. We've seen that our whole lives. But resistance, that's the strange part. Because when you hear resistance, you probably imagine something solid, a wall, a surface, a push you can feel. But inside an atom, there is no wall, there is no surface, there is mostly nothing. And yet, that nothing behaves as if it says, you can't come any closer without paying a price. Think about squeezing a crowd into a small elevator. At first it's fine, people step closer. They adjust. But keep pushing. Force more people in. Eventually, it becomes unbearable. Not because there's a physical rule written somewhere, but because compression itself creates discomfort. Now remove the people, remove the walls, remove even the idea of bodies, and still something like that discomfort remains. At the atomic scale, being squeezed too tightly is not forbidden. It's costly. And nature always asks the same quiet question. Is this cheaper or is that cheaper? Electrons don't ask permission, they don't plan, they don't think. They simply exist in the cheapest arrangement allowed. And collapsing all the way into the center is not cheap. This is where many people get confused, because we're used to thinking, lower position means lower energy, closer means calmer, stillness means rest. But that intuition breaks down completely, because at very small scales, stillness is not peaceful, it's stressful. Imagine trying to hold a spinning top perfectly still, frozen in midair. It's unnatural, it takes effort. Now imagine forcing something that wants to spread out, to stay pinned to a point. That pinning itself requires energy. So when electrons stay spread out, it's not laziness, it's efficiency. They're not avoiding the nucleus because they're scared. They're avoiding paying a higher price. And this idea is so important that I'll say it again differently. Atoms don't exist because particles are balun. CD like weights on a scale. They exist because squeezing reality too tightly makes it fight back. Not with anger, not with force you can see, but with rules that quietly punish excess confinement. This is why pictures of electrons as little dots are misleading. Dots are too neat, too calm. Electrons behave more like tendencies than things, like possibilities that refuse to be nailed down. If you try to say, you are exactly here, nature responds, then you will pay for that certainty. So atoms settle into a fuzzy arrangement, not because it's sloppy, but because it's optimal. This is deeply unintuitive. We're used to thinking clarity is better, sharp edges, clear positions, but the universe prefers ambiguity when ambiguity is cheaper, and that's unsettling, because it means reality is not built on firmness, it's built on allowance. Now think about this for a moment. Every solid object you've ever touched feels rigid, reliable, hard. But that hardness is an illusion. It's not solidity. It's resistance to further confinement. Your hand doesn't pass through the table not because the table is full, but because pushing the atoms closer together would cost too much. So the table pushes back, not consciously, not actively, but inevitably, and this changes how you see strength. Atoms are not strong because they're stiff. They're strong because they are already as compressed as they can afford to be. Push further, and the cost skyrockets. That's why matter holds its shape, not because it's locked, but because unlocking it would be too expensive. Now pause and let that sink in. Everything around you exists not because it's perfectly arranged, but because rearranging it would be worse. Stability is not a final state, it's a truce. And this truce is enforced by rules that don't care about intuition. Which brings us to something even more unsettling. These rules don't explain why nature behaves this way, they just describe that it does. And Feynman was always honest about this. He never pretended we had a comforting story at the bottom. We can say this is how it works. We can say this is what happens if you try to squeeze too much. But when you ask, why must it be this way? The universe doesn't answer. It simply insists. And maybe that's the most honest part of physics. Not that we understand everything, but that we know where understanding stops. Atoms exist because collapse is forbidden not by walls, but by the price of certainty. They hover because nature dislikes being cornered, and once you see that, you start noticing the same pattern everywhere. Stars don't collapse instantly. Matter doesn't dissolve. Structures persist. Not because the universe wants order, but because disorder, pushed too far, becomes expensive. This is not a comforting idea. It means existence is not guaranteed. It's negotiated moment by moment. And now we're ready to step back and ask a bigger question. If matter itself exists only because reality resists being too precise, what does that say about us? About knowledge, about certainty, about the limits of thinking? That's where we'll go next. Now let's step back. Not into equations, not into deeper machinery, but into meaning. Because once you understand that atoms exist only because collapse is too costly, you can't unsee it. You begin to realize that the universe is not built on certainty. It's built on limits. Limits on how much you can know, limits on how tightly you can squeeze, limits on how clean reality will allow itself to be. And this is where human intuition quietly breaks. Our intuition evolved for rocks and trees and falling objects. It evolved to survive, not to understand existence. So when we demand simple explanations at the deepest level, we're asking reality to speak a language it never learned. Atoms don't exist because they want to. They exist because reality refuses extremes. Too close? Too expensive? Too certain? Too costly? So matter hovers in between. This should humble us, because it means the solid world we trust is resting on something deeply unstable, a permanent negotiation, a delicate compromise that never quite settles. Every breath you take depends on this refusal to collapse. Every star depends on it. Every thought in your brain depends on atoms being allowed to exist just enough. Not perfectly, just enough. And that's a strange foundation for reality. It tells us that the universe is not engineered for comfort. It doesn't owe us clarity. It doesn't care if we find it intuitive. It only cares about what is allowed. And allowed does not mean obvious. Think about this. The same principle that keeps atoms from collapsing also limits how much you can know about them. The moment you try to pin things down completely, you disturb them. Knowledge itself has a cost, and that's unsettling. It means reality is not something you can fully hold, only approach. Feynman loved this idea, not because it was frustrating, but because it was honest. He understood that physics is not about moving mystery. It's about discovering where mystery lives. Atoms don't remove mystery from the world. They hide it inside everything. Inside your hands, inside your eyes, inside the silence between your thoughts. And once you accept that, you stop asking the wrong question. You stop asking, why is this solid? And you start asking, why is collapse avoided at all? And there is no final answer to that, only deeper rules and deeper limits. This is not a failure of science. It's its greatest success, because science doesn't promise certainty, it promises honesty. And the honest answer is this: matter exists because reality resists being pushed to extremes. Not because it's designed, not because it's balanced, but because the universe charges a price for certainty. And perhaps that idea reaches further than physics. Perhaps it applies to life, to thought, to identity. The harder you try to define something perfectly, the more it slips away, the tighter you cling, the higher the cost. Atoms teach us that existence is not about control, it's about allowance. They teach us that stability is not stiffness, it's flexibility within limits. And that might be the most uncomfortable lesson of all, because it suggests that the universe is not built on answers, but on boundaries. Boundaries that say, you can come this far and no further. And we live inside those boundaries. Every solid thing you touch is a reminder of that refusal, a quiet protest against collapse. So the next time you hold something in your hand, don't think of it as solid. Think of it as reality saying, this is as far as you're allowed to push. And then ask yourself something even more unsettling. If matter itself exists only because reality refuses extremes, what else in your life exists for the same reason? And what would happen if you tried to push too far? That question has no answer, and maybe it's not meant to. Maybe understanding atoms doesn't give you comfort, it gives you perspective. And sometimes that's the most honest gift science can offer: silence.